Hi there. What I've got here is an 8-step multi-sequencer for Eurorack based around an Arduino, and what I'd like to do is just go through some of the hardware that I chose for it, and then I'll have a look at the software, just see how it operates. Initially, when I was looking at an Arduino, I wanted to make it an Arduino based sequencer. Have a look online at various sequencers, various reviews, and some DIY ones as well. So it gave me some ideas as to what I was wanting to put into my sequencer. I wanted a display, and so I chose it's a 2-line 16 character display. I also wanted individual steps, or to select individual steps. That's what the switches are for, and I've got a rotary control which we can use to adjust anything in the sequence, start stop button. I've also got separate gate outputs. I like the idea of that, for not only just CV out, we can actually do controlling as well. But we've got the usual things. We've got clock out, gate out, CV out. We've got start stop, reset, CV in. The CV in, we can use that to control the speed of the sequence, and external clock in. So it's fairly standard bits and pieces. And again, I'd looked at initially the Arduino Nano, which I've used in the past, and whilst it's okay, it just doesn't have enough input-output pins to handle what we're trying to do here. Now, I'd looked at the using expander ICs, at the 4051 IC. It's an 8-into-1 or 1-to-8, depending which way you use it, but it meant that you had that, you had more chips, and it just started to get a bit messy. I was going to have to build a board. The width of this was really dictated by how much space I had left in my case, so it was just enough space to get this kind of layout on a board at the back, but I knew I'd have to make a daughter board for the Arduino for the control. So what I ended up with is this fellow here, which is the Mega 2560 Pro Mini, and that has got lots of I/O, more than enough than my needs are here. The only major difference is, other than the size, is the Nano has 2 lines coming out of header pin, and you can just stick that into breadboard, or you can stick it into a bit of strip board and solder it, what have you. The Pro Mini has got 2 rows of pins and around the edges, and that does create a bit of a problem. You can't just put that into a bit of strip board without cutting the tracks underneath the strip board, and it gets a bit messy. So what I opted for was, well, you could solder the wires onto each point, but the problem with that is, if for some reason you want to change which pin that you're using to connect to whatever, you'd have to unsolder it and solder it back onto another pin. But if you damaged the Arduino in the process of developing the unit, then you'd have to unsolder all the pins and then solder on a new chip or a new board. So I opted for putting the header pins, and I also got this, which is just a box of header hoods, and you can get either the pins or the sockets. You get the sockets there, so you could make that up. It's a bit more work, but it does give me the flexibility to chop and change things. And my thinking was either have a board with wires coming off of it, or I'll have a bigger board with wires coming off of it, so it was a bit of a no-brainer. But if you were developing a board for designing a PCB for it, you would just design it with this, the Arduino itself, on the board, and you'd be probably able to get everything on the one board. So it's very much a prototype. So what we end up with is this, which is quite a bundle of wires. But as I say, it's very much prototype, and we have, if I actually quickly show you, here what we have is the Arduino Pro Mini. We've got 8 pins here for the sequence LEDs, just the flash to tell you which step in the sequence you're on. The gate, this is for the extra gate outputs, we have them lighting up, so you get the first 6 there and the next 2 there. The LCD display, what I've done with that is typically you would use 4 data lines and the RS and enable line to talk to the LCD display, but because we've got the luxury of so many pins, I decided to just populate all 8. It also means that we're writing to the display in 1 byte rather than 2 4-bit nibbles, so it'll be a bit faster, but it's just with the luxury of that anyway. So sequence keys, fairly standard thing, used internal pull-ups on the Arduino, and we just pull these to ground on the switches. Rotary control, 2 pins for that, for clockwise, anti-clockwise. The rotary switch, when you push the rotary control, just pull up on that, pull it down. The run stop key, again, is just pulled to ground. Gate output, for all the sort of digital outs, what we're doing is we're just taking the output through a 1k resistor to the socket. It's a fairly common way of doing it. If you were going for a production unit, you might want to buffer that slightly, but for the moment, and I haven't broken anything yet, it's still the original board. External clock in, again, a fairly common technique is just use a buffer transistor. You get these things on tutorials on YouTube, fairly common thing. Reset, same idea, it's just an external input with a buffer transistor. External run stop, exactly the same idea. Analog input, I have that going in through a multi-ton pot with a protection diode on that, just to protect the analog input from any high negatives or high positive voltages. And we've got a 5-volt regulator on board, and we've got ground. And that's more or less it. And everything we're doing here is fairly standard stuff. It's something that you can, there's lots of tutorials on the LCD display. This is the DAC, it's just a fairly standard DAC, just 3 pins to that. Again, there's tutorials on YouTube on how to, you basically send a number to the DAC and it just outputs a voltage. The output from the DAC we're feeding into an op-amp, and we've just got a variable gain on the output, so we can then get a 0 to 7 volts range and 1 volt per octave. So that's, again, nothing new in that. Everything's just, it's pulling on all the stuff that's readily available. So if we look at the unit itself, as I say, it's you've got all the sockets at the top. You've got the 5-volt regulator here. There's the multi-ton pot here. I've got actually for contrast for the LCD display. I've got a multi-ton pot here for adjusting the analog input. I've also got that's the DAC, and inside there's the op-amp with the multi-ton pot to adjust the 1 volt per octave. Down the bottom I've got the buffer transistors. So it's a bit of a spaghetti junction, but that's just the nature of a prototype. As I said before, if you could design a whole board, even one that would take the sockets and have everything on the one board. So you would do that if you were going into production with something like that. But for the moment, that's and it hasn't really changed an awful lot since I first put it together. I've added a few more sockets, but other than that, it's been quite reliable hardware-wise. So that's more or less it at the moment. What I'll do is I'll put it in the case and then I'll run through the software and just see exactly what it can do. Okay.